Hey, welcome back to Fully Defined, and this is the Build and Learn series where LEGO builds and SolidWorks skills come together. Now, this episode, we've completed our LEGO Off-Road Buggy, but we still got a number of issues with our assembly, and we're going to identify those using the Interference Detection tool in SolidWorks. So, Interference Detection is a really powerful tool used in assemblies to find where two parts are overlapping where they shouldn't. So, I'll take you through how that tool works. You can see my workflow. You can see a couple other tips and tricks I use to identify the errors in my modeling and fix those interferences. And if you haven't already seen, or if you've been following along or maybe just jumped in for this video, if you want to see the finished file, follow the description in the link below, sign up to the mailing list, and you can download your complete set of SolidWorks parts, SolidWorks 2023, or step file assembly, which you can then import into your own CAD software to play around with similar tools. Thanks. Let's check it out. Hey guys, let's get into it. Now, to start, what we're going to look for is interference in our parts. Now, this is one of the key SolidWorks assembly tools that I use, design validation, going through the process of checking my files, making sure that they've been designed correctly, I haven't missed any features, and mostly to know that things are going to fit together. Now, in this type of object with 100 parts plus, it's hard to keep track of everything. All right, as simple designs, only got a couple parts, much easier. But in this sort of thing, you need to use the tools to assist you to stay on top of any problems. To find assembly interference detection, we go into evaluate. That's the first item here on the left. After design study, we go to interference detection, and I'll take you through what the settings show. So first, your selected components. So with nothing selected, it selects the whole assembly, but you can also clear that selected components box, and you can actually just select a couple of parts. For instance, I can click the wheel and the hub here, and that will just calculate the interference between those two items. All right, so if you had it in a sub-assembly or a couple of elements and you just want to check those, select them in that box, press calculate, and then that will run the interference detection just on those items. This is very useful if you have an extra large assembly, because obviously when it's calculating the interferences, if you have a lot of interferences or things that are very small across a number of parts, it's going to take longer to calculate. So that can speed things up. You can also exclude. So if I just click interference detection, it's got the assembly selected as default. If I click exclude components, I can say, okay, actually I don't want to worry about these wheels. So any interference caused by those wheels, it will ignore. You can hide components from view as well. So you could actually go through and click off everything that you know is not an issue. I've never used that tool, but it is there. Now down here in the bottom, there's a couple of important steps just to be aware of. Treat coincidences interference. Okay, so that's when you've got two parts that are touching, but they're not intersecting. Now that's normal. If you look at our assembly here, we've got lots of these parts that are coincident, like the green on the white here. If you tick that box, it's going to highlight that as interference, even though it's not necessarily interfering. Show ignored interferences is when you've already done at least one interference detection. It's come up with the results. In those results, you can actually ignore an item. Usually you might do that kind of thing on a nut and a bolt, for instance, where the threads are interfering. That's one example. Treat sub-assemblies as components. What that means is if you have a sub-assembly within your assembly, it's not going to actually pick out the interferences within the sub-assembly. It's only going to show outside the sub-assembly. So if you've got two sub-assemblies together, and there's interference between those two, it's just going to highlight those two sub-assemblies, not every individual part. Include multi-body part interferences. That's where you've got a single part file that has multiple bodies, and it will highlight those interferences for you. In this file here, we have no multi-bodies. Everything is a single body per part file, making interfering parts transparent. Once it's done the calculation, as you select one of the interferences, it will make them transparent so it can actually see, and it's highlighted in red, the element that is the interference. And then at the bottom here, create a fastness folder. So if you're using toolbox parts or parts that are highlighted or indicated as hardware fasteners, it'll actually put those in its own folder because they normally have interference, which you generally ignore. And the last, creating matching cosmetic threads folder. I don't really touch that, don't use that much. Ignore hidden bodies components. I use that regularly. Usually when I am working in multi-body design, I may have certain bodies in a part file, which are there as reference and are hidden, and I don't want them considered part of the interference detection. So that's a good one that I regularly have checked. The non-interfering components here, okay, those are different view types, okay, depending on your current view settings for once you do interference detection. So let's do an interference detection and see what issues we have in this assembly. And that little sound is the end, the indicator of the detection process. And you can see in the list here, we got a long list of interferences. Now, the way that list is prioritized is largest interference to smallest. So always the biggest, most important ones will come up at the start. Now, what you'll notice is we can see here, it's highlighting the first interference. Now, when you click on each of those interferences, so you click on one to the other, you can see it will move around to show you where those interferences are. Now, if I press the tick or the cross, nothing happens. Interference detection is just an evaluation tool. Unless you save a report or create a folder, nothing's really going to happen from that. And if I open it up again, I have to redo the interference detection. In this case, it's only taking a few seconds, so it's nothing really to worry about if you do close that accidentally. So let's assess this first interference, and let's just look at the non-interfering components. So we can change to wireframe, hidden, transparent, or use current. Just depends on your product, okay, which option you might want to use. Hidden is pretty good because that's kind of like isolating those two parts. And now as we turn around this object, we can see that it is this section between the white inner hub and the black of the wheel. Now, if I press the drop down on that item, I can see the two parts in question. And when I click on them, it will isolate them. When I click on back on the interference, it's going to highlight in red where that interference is. So now that I've got that interference there, what can I do about it? Well, let's press the tick and let's go, and I'm going to work on these two at the front, remembering that these are all the same parts. I'm going to isolate these two, and I'm just going to make the outside one transparent to try and get an idea of where that interference is. And I think it's in around here. Let's try a different view. Let's try a section view, and we can see the front plane of the assemblies going through this wheel. There we can see our interference, and it's pretty clear looking at this. Now let's change this to transparent, and you can see the interference is in this section. All right, so this is probably where we've made some errors in measuring, perhaps, or assumptions on the part. I'm going to pick up the part and have a look. Okay, so here we can see the two parts, and the way they're assembled as on the screen is like this, okay, with this part facing outwards and this part facing outwards. Now, the white hub, that was quite easy to measure, and I'm pretty confident in the accuracy of my K on that part. So I think the interference is going to come from the wheel. Now, when I'm looking at the wheel and the detail on the screen, where that overlap is, we can see where that's coming from. That's this section in the middle here. Okay. Now, I have already identified where I think the problem is. Now, I'm going to use the calipers here to measure how far that little step section sits inside. Okay, so from the back face to that edge, I'm getting around, yeah, it's not perfect, but getting around 5 millimeters, a little bit over. If I'm looking from this view, it looks like it's the same distance, but not from this front face, it's from this edge of the chamfer. And I think that's where I made my mistake, because I put that chamfer on after detailing this product. So I think that that edge actually sits from the front face, maybe about 11 millimeters. So let's make that change in the CAD and see how that impacts our interference. So if we jump into the CAD now, I'm going to edit this part and I'm just going to go to this front view and let's look to where that detail is. And we put it in as part of the revolve and you can see that's part of our problem. Okay, we've put it perfectly in the center, but it actually should be offset towards the back. So let's fix that. Let's take this midpoint, delete it. What else do we have to change? This mirror, we're going to have to delete, and this mirrored relation. Now these lines stay collinear, but it's this section that's going to move across. All right, and now we start to get an idea of maybe where it should sit. Now we're measuring approximately 5 millimeters from the back. And you see when I put that dimension in, that sits nearly perfectly with that gap in the white hub. Now maybe this 0.6 is a bit over the top. Maybe it's a little bit less. So we could drop that back. Or that's not quite right either. That was this bit here, 16.2. Okay, let's just bump that up a little bit. Put this back down. All right, and I'm going to settle on that. The way to get this perfect would be actually slice this part in half so you can get a proper measurement, and I don't want to do that. So we're going to leave it here. That's caused some errors in that part, so I'm just going to open that part on its own. Just correct that circular pattern error. Oh, I've lost some detail here, so see what's happened there. So we've got our cut revolve, our revolves, cut revolve, surface cut. There you go. So when we cut it and put it back in, we've lost that revolve, that little section in the middle. So what we'll do is a new sketch on the front plane. We'll convert that sketch. I'm going to delete all of those elements and replace that one. Guys, I'll put a construction line in the middle to revolve around. And then I'm going to revolve that. Let's put that little bit of thickness back in. Now my circular pattern, I can once again, I can pattern around any edge. I didn't need it there, but I can just update that. Put the chamfer back in and my boss extrude at the end. Now if we do a section view again, and we have a look, we have 5 millimeters from the rear and we have 9 millimeters from the front. So maybe it's a little bit smaller than this. So why don't we just reduce it 3.5. I also want to still keep it in the middle of that. So go 5.25 or a better way to do that. No, that's fine. Let's leave that. Okay, let's save. Back to the assembly. Let's have a look at the section view again. We can see, look, it's sitting neatly in the middle of that area there. Now, it is possible that those faces actually have a chamfered appearance. Okay, so why don't we try that? That's this section here. If I just delete that relation and that relation, I can tweak, give them an angle, I can make them equal, and I can set that angle. Let's say it's 70 degrees. Once again, we're getting a bit closer. We still have interference, but you can see how now our dimensions actually weren't that far off. Let's try another couple of steps. Just want to isolate this part again. I'm going to just open it on its own. I really think we can get to a point where there's no interference on this part and our detail will be correct. I'll go back to this revolve. I'm going to delete that dimension. I'm going to put a midpoint dimension from the origin 2. I'm going to reduce this 3.2. Can save that. Have a look here. And now look at that. No interference between these two parts. Now that kind of modeled appearance that you get on these faces, that's showing you that those two are coincident. Right, but that's not a problem. Now, we've got some errors in our assembly. Let's quickly replace or repair that. Just going to isolate the sub-assembly and work out what's gone wrong. So to do that, I'm clicking on the part. I can see that error in the mate. We've probably lost the relationship of that round face. Just going to change it to this, reverse. Oh, it's causing a few errors. It's not great. Let's undo that. Let's try it a different way. Because right now there's no errors. Sometimes you just need a rebuild. Okay, no problem still between these two parts. Just going to isolate. Sometimes with mates, what you can do is actually click and drag. It says they're fully defined and fully defined. Let me open this virtual subassembly. Try it this way. Here. Now this is something that we never corrected properly. Maybe we should. Here. these two, missing a face to mate that round one. Now, there's no errors here, but it's underdefined, and I don't really like that. So let's take this part and use it to mate. Is this the best way to do it? Probably not, because these are referencing different parts. Now we're getting a few errors. Oh yeah. Okay, let's fix it up properly. This part's going to be our main component, the subassembly, as in it's going to be our first one that's fully defined. Okay, so then we can see this one comes in, and this one needs an additional mate from this face to this face. And then the tire, all we need to do is lock the rotation. All right, now our subassembly is fully defined. It only took a couple to get it done. I've saved and closed, and we're back to normal. And now, back to where we were at before. Let's do another interference detection. I'm just going to do it between these two parts. Calculate. No interferences. If I clear everything, I go calculate, or I click that across, click interference detection, click calculate. See those large interferences that we had before in the wheels? They're no longer there. So we've progressed through to the next rank down of interference. So let's have a look at that. There's a few examples of it. This one is a interference between two of the plastic parts. Can we do a section view? Oh, it's a bit hard to isolate them. I think it's these ones in here. Let's do a section view, and there we can see the problem. Very obvious problem. Looks like we've modeled something wrong in the detail of these, right? Because there's no way, obviously no way that they would fit together like that. So what should we do? Probably pull our assembly apart and just have a look. Okay, well, I've definitely made a mess of my little model. And I can also see the problem with this file here. It's this one. Now, this was an inverted part, but there is no extrude here. So if I suppress that, that now looks correct. And save that, go back in, have a look, and now there's no interference. Okay, so it's helping us to identify the errors in our geometry, or sometimes it might be a feature that you have suppressed or unsuppressed accidentally or incorrectly that's causing the issue. Let's continue. Let's see what other interferences we can find. Now, sometimes you don't even need to use the interference detection tool. You can actually just use your eyes. I'm going to show you an example of that. That is by using the section tool. It's by doing a section view. So I'm doing a section view just straight down the middle, and I'm just going to have a quick look over everything. So we know that we haven't been perfect with our modeling. So there's a lot of inconsistency with our parts and how they sit. Some look really tight. Some look a bit loose. Some definite interferences, like here, for instance, here. Right, some elements that'll have to change here. Another mistake. Up here, interference around these pins. Interesting. Right, so there, it's like, well, I probably measured that one correctly, which means this one's probably wrong. You know, if I just click on this one, click on that shape, where I've got 3 in the middle, let's just change that to 3.2. Now, why do I say that that one's more likely wrong? Well, it's because it's much easier to measure the outside of something like this. That is the inside face. Okay. Let's just have another look through over this side. Those parts looking okay. So like this is really tight, but that's okay. There's a bit of an error there in that part. Let's fix that up while we're here. So that boss extrude, we're done. Offset from surface. It's going up a bit high, but we should also go direction 2 up to next. At least does that little section there. Okay, that's better. More interference over here on this white one. Now, would that be on this black piece? Probably. And that looks like that is on some ribs. So let's go back to our section view again. Right plane. Then what's good about being in assemblies like this, where can we see that error? I think we must have moved our view. That's here. You can just edit on the spot. So I can just click on that part, click on this feature, because I dimension it like this, type in the new dimension, bring that edge back to off a bit less. So I can see then it's no longer interfering, close that. And when I save, well, it's saving all the individual parts as well as anything in the assembly. So that's cool. Now these ones are interesting because either these rounds or these rounds are too big. I don't know which. Similar for that one. So that's 6.8. What part is that? It's the bottom of those. That 6.8 again. So that's an easy one to measure. But so is these 4.8. That's the bottom of a standard type part. So that's actually pretty easy for me to access one of those, just on the top of my model. So if I was to measure one of those elements again, I do have digital calipers coming. I just need a battery. Measure one of those again, and I'd have to say it's closer to 6.4. So I'm going to edit that, click on that one, change to 6.4. Does it still have interference? No. See, it clears it. Now that's a good change, but I've got quite a few parts like that I will need to update, like these ones at the top here, because I've used that 6.8 very regularly. So we're going to need to make a lot of changes throughout our files to get that up to date everywhere. Here's another example. Now this one we would never know because it's actually not touching another part on the bottom. So it can be challenging doing that kind of change. All right, so we've only addressed a couple of interferences there. Let's just save, do another interference detection. And you can see our interferences, they're now getting, there's less of them. There's still a lot, 133. But there's a lot here that are 0.19, 0.22. I'd say as we go through and, adjust some of these sizes, it's going to make, like a lot of them are going to get removed if we fix whatever it is, this one. So there's an interference here. Now, that's the top of those bricks. Oh, that is a commonish type part. But it's also just the rib that's on the inside pushing against it. That part is this one, 4.8. I think that's right. So there must be something else. All right, so now let's get into eliminating the rest of the interferences by updating any part that has an issue, a size issue. This one's really interesting when I look at the green part up close. It's actually got a little hole in the front because the cut actually passes so far through it. So, yeah, that's like it's a very neat little detail in this part. I'll just isolate these two. This hole here, 4.8. So there's about a 5mm hole that goes through this one. So let's see if we can put that in. On this face. I'm going to draw that hole. Just going to get the right references, because it should be in the middle of this part. Okay, so this, no, it's going to be top, no, it'll be like that midpoint and that. There we go, that looks pretty central. And then that cut. What does it normally go? 0.8. It's bigger than that. 1.6. So it's at least going 1.8. And you see it'll just pop through that corner. So that might be right on the edge. We might get an error. Yeah, zero thickness geometry, which means the shape actually needs to be a little bit bigger. 5.2, 1.8, and then we get that little hole. And that's exactly how it looks in the part. Trust me. Okay. All right, there we go. That only took 20 minutes and we've got no interferences. Now, we may still have some inconsistencies in our parts, but the process here was to eliminate those interferences. Checking part detail one by one is something you would go through when you're doing production drawings, okay, or other inspections. So, yeah, happy with that process. Hope you enjoyed the video and catch you in the next one. Hey, thanks for watching all the way to the end. Really appreciate that. This has been the LEGO Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.